Hi everyone, welcome to another video. Today we're going to be looking at circles, circular angles and arcs. So let's start by looking at some of the most important properties of circles. All points are equidistant from the center. This distance is called the radius. Diameter is twice the radius. It passes through the center, connecting 2 points on the circle. This is the center of the circle, and this distance from the center all the way to any point on the circumference, this distance is called the radius. And any point on the circumference is equidistant to the center of the circle. If we look now at this line here, this line that divides the circle into equal parts is called the diameter, and it's equal to 2 times the radius. This is the center of the circle. This is a radius and this is a radius. The entire distance of this line is the diameter. Let's continue looking at the properties of circles. The circumference is the perimeter of the circle, and the formula is circumference is equal to pi r. R is the radius, and remember that pi is a constant equal to 3.14. The area of a circle is equal to pi r to the power of 2. A central angle creates an arc. The angle's vertex is at the center of the circle. And we're going to look in a moment at the different types of circular angles. One of them is the central angle. Another one is the inscribed angle. Then we have the internal angle or the interior angles, and then we have the external angle. So let's look at this one, for example. A central angle creates an arc. The angle's vertex is at the center of the circle. This is a central angle where the vertex is at the center of the circle, and it's created by 2 chords or 2 segments that end on the circumference and intercept an arc. This is the arc, this portion. Let's continue. An inscribed angle is half the measure of its intercepted arc. An inscribed angle is like this one, for example. This is an inscribed angle where the vertex is on the circumference, and we have 2 chords that end up on the circumference of the circle. The vertex again is on the circumference, it's not in the center of the circle. This type of circular angle is called inscribed angle, and the arc is equal to 2 times the value of the angle, or vice versa. The angle is equal to half the arc, this part of the arc that is being intercepted. Let's continue now with some more properties. Tangent lines touch the circle at exactly 1 point, and we're going to look at tangent lines in a moment. And they are always perpendicular to the radius at the point of contact. A secant is a line that cuts through the circle, intersecting it in 2 points. Chords are line segments with both endpoints on the circle. All radius in a circle are equal. Let's see now the types of circular angles and arcs. A central angle creates an arc. The angle's vertex is at the center of the circle. Its measures is equal to its intercepted arc. And here we have an example of a central angle. The vertex is at the center of the circle. We have two chords that end, each one of them on the circumference, creating this central angle. And this arc is equal to this angle. We're talking so far about measurements of the arc. We're not talking about lengths of an arc. We're talking about measure of an arc, which is the portion of the circle that this arc covers. Let's call it a slice. This arc covers this measure or this portion of the circumference. But again, we're not talking about lengths. Lengths is something else. Here we're talking about angles. This arc, in this case, the measure of this arc is equal exactly to the central angle. And again, when we talk about measure, we're talking basically about the portion that this arc covers from the total area of the circumference. Let's look at the second type of angle. An inscribed angle is half the measure of its intercepted arc. The vertex is on the circle, on the circumference of the circle. Sides are chords or a tangent and a chord. Like this case, inscribed angle, the vertex is on the circumference of the circle, created by two chords, intercepting this arc, and this arc is equal to 2 times the angle, or vice versa, the angle is equal to half the measure of this arc. This type also is an inscribed angle where we have a chord and a tangent, and this angle here is half the intercepted arc, which is this one. Another example of an inscribed angle. The third type of angle is interior angle, not central or inscribed. The vertex inside the circle, not at the center, formed by two intersecting chords. Its measure is half the sum of the intercepted arcs. And this is an example of an interior angle. They intersect in any point other than the center of the circle, and they create two arcs, a small arc and a large arc. In this case, and of course these two angles are equal, so the interior angle is equal to the two arcs added divided by 2, and this is the formula. Interior angle is equal to arc 1 plus arc 2, or arc 2 plus arc 1, doesn't matter, divided by 2. And the last one is exterior angle, vertex outside the circle formed by two secants, or a secant and a tangent, or two tangents. Its measure is half the difference of the intercepted arc. And this is the external angle. The angle is outside the circle. It creates two arcs, a large arc and a small arc, and the formula, the angle is equal to the large arc minus the small arc divided by 2. The diameter is always perpendicular to a tangent line, creating a 90-degree angle. So let's do a quick review of everything that we've seen so far. Circle area is equal, or area of a circle is equal to pi r square. Circle perimeter is equal to 2 pi r. Measure of an arc. Remember, we were talking about measure and length of an arc, two different things. A measure of an arc, it's an angle expressed in degrees or radians. 1 radian is equal 180 divided by pi. Approximately, we're talking about 57.29. The measure of an arc is an angle. It tells you what fraction of the whole circle the arc covers. For example, if an arc spans a quarter of a circle, its measure is 90 degrees or pi over 2 radians. Now, the length of an arc is a different case. It's a distance expressed in unit, whatever the unit is, centimeters, meters, inches, yards, miles, whatever. Arc length is equal to the arc measure, which is the angle, divided by 360 times 2 pi r. Example, if a circle has a radius of 10 centimeters and an arc measures 90 degrees, the arc length is 90 divided by 360, which gives me the portion of the total circular angle of a circle times 2 pi r, which is the formula for the perimeter, the circumference of a circle. Again, we're looking here at a central angle. The angle starts at the center of the circle, created by two chords that end on the circumference of the circle. And the measure of the arc, notice that we are not talking about length, we're talking about measure. The measure of the arc is equal to the angle, in the case of a central angle. In the case of an inscribed angle, the arc is equal to the angle times 2, or the angle is equal to the arc divided by 2. This is another case also of an inscribed angle. The vertex starts from any point on the circumference of the circle. An interior angle, two chords that intersect on any point other than the center of the circle, creating two arcs. One arc that goes all the way from here to here, and another arc that goes all the way from this point to this point. And the formula of the angle, this angle or this angle, which are equal, is equal to arc 1 plus arc 2, or arc 2 plus arc 1 divided by 2. The external angle is outside the circle, created by two tangents to the circle, intercepting two arcs. A small arc and a large arc that goes from this point to this point. And the formula is arc 1, which is the largest arc, minus arc 2 divided by 2. Again, this is the large arc, and this is the small arc. So this angle is equal to the large arc minus the small arc divided by 2. So remember we said that in the previous slide, I think this one here, if we wanted to calculate the length of an arc, it's equal to the arc measure or the angle divided by 360 times the perimeter of the circumference, which is 2 pi r. Now let's say I want to find the area of a slice of the circumference. Let's say I have the angle, so the angle divided by 360 would be a complete angle, a complete circular angles. So if I want only this portion here, it would be the angle, whatever the angle is, divided by 360, which give me only this portion, times the formula for the area of a circle, which is pi r square. And this would give me this slice, the area of this slice. Let's now try to do some exercises. Okay, so let's start with the first exercise. And in this exercise we need to find angle x, this angle here. Now the first thing we need to think is, what type of angle is this? This is an external angle, right? And we know that the external angle is equal to the difference between the two arcs created divided by 2. Where are the two arcs created? We have this arc here, and we have another arc, which is this one. So we have two arcs. Now one of them is being given. The orange one is the measure of the orange arc intercepted by this external angle is 105. The yellow one we don't have, but we know that a circle, the total circular angle of a circumference of a circle is 360 degrees, right? And if we have that this arc is 105, so it's very simple to find how much is the yellow arc. So 360 minus 105 is equal to 255, right? So now we know that this arc, the yellow one, is 255. And we know that the formula to find the external angle is equal to the difference between the two arcs created by the angle divided by 2. So x, the angle x that we're looking for, is equal the difference of the two arcs, right? 255 minus 105, and this gives us that x is equal to 75 degree. Simple enough. Remember, the first thing we need to know in this type of problems, arcs, circles, and angles, first we need to know what type of angle we are dealing with. Is it an external angle? Is it an inscribed angle? Is it a central angle? Is it an interior angle? So once we know what type of angle we're dealing with, we can apply the theory and the formula. Now let's move to another exercise. And in this one, we need to find the angle theta. Now, what type of angle is this? This is also an external angle, and we have two arcs created by this angle we have. This arc, 51, and we have this arc also here. Let's highlight this arc here. The big arc, right? This arc. And we are being given both arcs, the small one and the big one, the large one. The small one is 51 and the large one is 141. And we know that external angle is the difference between the two arcs, the large arc minus the small arc divided by 2. So the angle that we're looking for is 45 degrees. Let's move now to another exercise. Now remember, always the most important thing is to know what type of angles we are being given. And then depending on what type of angle we are being given, we can apply the theory. No matter how complicated a drawing might be, always try to identify and isolate the angles that you are being given. Now, for example, in this example here, we have two different angles. If you look at this angle here, what type of angle is this? Yes, exactly. This is a central angle. Now, what type of angle is this? We are being asked to find angle ADB. ADB. We need to find this angle here. Angle ADB. Now, what type of angle is angle ADB? Exactly. Yes, this is an inscribed angle. And this one here is a central angle, right? This one is a central angle. Now, notice this. Both angles are intercepting the same arc. this green arc is common to both angles. The central angle is intercepting this arc, and the inscribed angle is also intercepting the same arc, which is this green arc. And we know how much is the central arc. The measure of the central arc is 80. And we know from the theory that the central arc, the central angle, the arc, the intercepted arc is equal exactly to the central angle. So we know that this arc is 80. A central angle, the arc intercepted by a central angle are exactly the same. They measure the same. So if we know that the central angle is 80, the arc is 80. Now this arc is being also intercepted by this inscribed angle, right? This arc is common to both. So by the information given here, that the central angle is 80, we were able to find this arc. But this arc also is being intercepted by this inscribed angle. But we know from the theory that an inscribed angle is equal to half the measure of the arc. So this angle here, A, D, B, is equal to how much? Is equal to half the arc AB. Is equal to half 80, and this is equal to 40 degrees. Let's move to another exercise. And in this one, we need to find this angle. Angle X. Now, again, always, it's the same process. We need to look at the type of angles that we have in this problem. And we have two angles, right? It's very clear. We have this angle, and what type of angle is this? This is a central angle, right? And we have also this angle. And what type of angle is this? This is, yes, an inscribed angle. Now, look at this. Both angles, the central angle and the inscribed angle, both of them are intercepting the same arc. This arc is common to both angles. This central angle is intercepting this arc BC, and also this angle, the inscribed angle, is also intercepting this arc. So this arc is common to both of them. And if we know how much is the inscribed angle, then we know that the arc is equal to what? Is equal to 2 times the angle. So we know that this arc is equal to 82, right? If we know how much is the inscribed angle and it's being given as part of the problem, it's 41 degrees, the inscribed angles. The arc intercepted by this angle, the inscribed angle, is equal to the inscribed angle measured times 2. But this arc is also intercepted by this central angle, and this is the angle that we need to find. But we know that the central angle is equal exactly to the measure of the arc. So we know that angle x is equal to 82. Let's move now to another exercise. Now remember, it's always the same process. We look at the data that is being given to us, we plug the information in the drawing, and then we start by identifying the type of angles that we have, because based on the angles that we have, we can find the arcs. Or if we are being given the arc, we can find the angle, but always depending on the type of angle that we have. Because depending on the type of angle, we can apply the theory, the formulas. Now, let's see. Here, we are being asked to find x. So, let's see. This arc is from here to here, it's 29x minus 1. And this arc here, from here to here, is 14x minus 7. And this arc that goes all the way till here is 29x minus 1. How much is this arc? This arc, yes, this is a central angle, so the arc is 10x. How much is this arc? Notice that this is a 90-degree angle here, you see? This is a 90-degree. And all of these angles are central angles. So how much is this arc? This arc. Yes, this arc is 90-degree. How much is this arc here? It's 40x minus 1. Because an arc facing a central angle is exactly its measure is exactly the same as the central angle facing it. So okay, and we know that the circumference, the total circular angle of a circle, is how much? Is 360 degree. So all of these arcs should be equal to 360 degree. Right? Simple. I mean, all these arcs complete a complete circumference, right? These arcs added complete a complete circumference, right? 360 degree. Because all these angles here are, when added, are 360 degree. They should be equal to 360 degree. So all we need to do is add all these arcs to how much? To 360 degree. So 29x minus 1 plus 14x minus 7 plus 10x plus 90 plus 40x minus 1 is equal to how much? 360 degree, right? And at the end, once you do all this operation here, we end up with x equal 3. Simple, right? Remember, a circle, the total circular angle of a circle is 360 degrees. And we have the arcs, right? And we know that all these arcs added should be equal to how much? To 360 degrees. Because that's what all the internal angles of a circle add up to, right? To 360 degrees. So that means that all these portions of arcs that creates the total circumference of the circle should be equal to 360 degrees. So all we need to do is add all these arcs to 360 degrees, do this operation, and I'll leave it up to you. You just have to put the numbers on one side and all the numbers with an X on one side, and you know. And then you're going to find that X is equal 3. This is algebra. Simple algebra, middle school, elementary school. All right? So, let's do another one. And in this problem, we need to find the yellow arc. So, what type of angle is this? Is this an external angle, a central angle, an interior angle? This is an inscribed angle, right? And we have that this angle here is 75, right? Now, this line here, this line, this is a tangent line, right? A tangent line. Let's put the tangent line here outside, and we have this line that cuts the tangent line and creates an angle here of 75 degrees. Now, what is this here? This angle. Isn't this angle the supplementary of this one that should be equal to 180? Right? This angle here is the supplementary of this angle, 75, because this entire angle here should be equal to 180. So all we need to do is find this angle here, and this angle is 180 minus 75, right? And this angle is equal to 105. This angle, this portion of the angle. Again, we have this line, and we have this angle. And this angle is 75. This angle here is the supplementary, right? And it's equal to 105. Because both of them should be equal to 180. Supplementary angles, okay? So how much is the yellow arc? If this is an inscribed angle, right? The arc is equal to 2 times the inscribed angle. The yellow arc. Yellow arc is equal to 210, which is the inscribed angle, which is 105 times 2. Okay, let's move now to another exercise. And in this one, we need to find angle BEA, the green angle. This angle here, the red one, created by these two chords, highlighted green. Now, what type of angle is this? Yes, this is an interior angle. And we know the formula, right? For an interior angle, the formula is angle BEA, which, by the way, is equal also to this angle, CED, right? It's equal to angle also CED, right? And angle BEA is equal to half the two arcs intercepted, which is this one CD, which is 100, plus the other two arc, which is this one AB, 60, divided by 2, right? So this angle BEA is equal to how much? 160 divided by 2, 80 degrees. This angle is equal to 80 degrees. Okay, so let's look now at this problem. So, again, it doesn't matter how daunting or how complicated a drawing might look like. It doesn't matter really. All you need to do is follow the same process all the time. Identify, well, first of all, of course, you need to plug the given information on the drawing, so this way it's easier, right? I mean, visually it becomes easier. Like I'm being given arc DE, okay. So it's equal 122. I have also arc AC, and it's 20, and arc DC is 90. Okay? So let's see, for example, let's say I need to find angle EAD. Let's say I need to find this angle here. EAD. Well, if you notice, angle EAD is intercepting the yellow arc, right? The yellow arc is the arc intercepted by this angle here. And we know that this angle, EAD, is what type of angle? It's an inscribed angle. And we know that an inscribed angle is equal to half the arc. So it's equal to 122 divided by 2. So 122 divided by 2 is 61. So we know that this angle here, this angle is equal to 61 degree. All right. Let's see, for example, let's see if I want to find angle this one, for example, angle AED, this one, this angle here. Let's see. This is also an inscribed angle, right? Yes or no? This angle AED. Let's see. This angle here AED is intercepting the orange and the green angle, right? And we know that an inscribed angle is equal to half the arc. How much is the total arc of this that is being intercepted by this angle, EAD? These two chords here, this one and this one, are intercepting the orange and the green arc, right? And we know that this angle that we're looking for is equal to half the measure of the arc, and the measure of the arc is 90 plus 20, right? Divided by 2. How much is that? 110 divided by 2, 55. So we know that this angle here is 55. All right. So what else can we find here? By the way, notice that this angle here is a 90 degree angle, all right? 90 degree. So, okay, let's say we need to find angle ADE, right? Let's say we need to find this angle here. Angle ADE. So angle ADE would be this angle here. This angle. Okay, this angle. Now let's see. This angle is intercepting this arc. Let's highlight it purple. This arc, right? This arc here. This is the arc intercepted by this angle, ADE, the purple, right? Now, how much is this arc? We know that the total circumference should be how much? Should be 360, right? So 360 minus 122 minus 90 minus 20 will give me what? Will give me this arc, the purple one, right? And if I divide by 2, I'm gonna get what? This angle here. You see, so this is how we approach this type of problem. First, we plug the information given in the problem, and immediately we take a deep breath and we see what type of angles we have and the information that is being given to us, so we can apply the theory to start finding missing sides or missing angles. And sometimes we have information also that is being given to us, like it's hidden, right? Like, for example, this one, this symbol here, we know that this is the symbol for a 90 degree. Okay, So, and this is how we play this game, simply looking and identifying at the type of angles that we have, and applying the theory to find missing arcs or missing angles. And the more information that we find, it will help us find other missing angles and other missing sides. So yeah, I hope this video was helpful, especially helping you with your assignments and homeworks. So good luck and see you next time.